Okay, moving into the second part of the lesson now. This part is dealing with performing linear regression or finding a line of best fit using Desmos. So on your second handout here, we've got a table that gives us some data representing repair costs for some vehicles given their age. So we've got the age of the car in years, and we've got the repair costs measured in thousands. And it says create a scatter plot of repair costs versus age. So switching over to Desmos, now I'm using the website. You can use either the website or the app if you have it on your own device. The functionality is basically the same between them. So if you want to use the website, it's just desmos.com. Once again, to enter a table, I've already entered it here just to save a little bit of time, but if you were entering one, you just click the little plus sign and then you choose the table option. Okay, but I've already entered the table here, and you can see the points plotted to the right on the graph. So now, in order to find the line of best fit, so the next part B says perform a linear regression using the command or formula y1 tilde, that's the tilde symbol, m x1 plus b. So basically your line of best fit formula with the tilde in place of an equal sign because it's a command that we're giving to Desmos. And the ones there, the subscripts, I'll just point out to you, they're ones because in the table they come up as ones. If I was to enter another table here now, see how it would switch to twos. So if I had more than one scatter plot at once, which you won't have, but then the subscript values are just referring to which table we're talking about. And so then in your formula, you would need to use twos if you wanted the line of best fit for that table. Okay, so let's get rid of that because we don't need another table. All right, so I'm going to click in space 2 here underneath the table. And you can use the keyboard on your computer if you're using the website, but I'm just going to use the Desmos keyboard here for you. So notice we don't need to actually type that one as a subscript. If I just type Y1, it automatically makes it a subscript. It knows, okay? And then you need the tilde symbol from your keyboard and M, and then X1 plus plus B. Okay, and then you'll see the line of best fit comes up on your graph. And notice over here in this box you have the value for M, the value for B, so the slope and the y-intercept, and also the correlation coefficient and the coefficient of determination are given to you there. So then if I go back over here, it says record the line of best fit. So I'm going to record those values right into my equation. So let's enter that here. So y equals 0.0979, let's say, 0.0979x, and then the b value is 0.9435 roughly. So plus 0.9435. 9435, and there's my line of best fit. Then it says record the correlation coefficient and discuss how well the linear model fits the data. So our correlation coefficient is about 0.28. R equals 0.28. So remembering from our scale in the first part of your lesson, that means this is a weak positive correlation. So the model does not fit the data very well. Now, notice what's happening here on this graph. Really, there is a fairly strong trend here in most of the points, but we have this point that's way above the rest. We have an outlier. Part D in your lesson says construct a residual plot and identify any outliers. So within Desmos here, if you click plot, notice it shows you these blue dots. The color may change, but it shows you this other set of dots that look very similar in placement to the ones from your original graph. So let's just make a note here. The residual value is the vertical distance between a point and the line of best fit. That's a very non-technical definition of residual value, but if you look back at your graph, notice that, for example, with this outlier point, if you look at the vertical distance between that point and the line of best fit, and then you look at its residual dot, that point is the same distance away from the x-axis. So that's what we mean by residual value. So the residual plot is just a little bit easier to look at because it plots the distance between the points and the x-axis. So it allows you to look at those points along the x-axis and see how closely clustered they are to the x-axis, which can be a little bit easier than when you're looking at a line that's running on an angle, the way most lines of best fit do, because that can just make it a little harder to see how far away the points are, I guess, from the line of best fit. So again, the more closely these points were clustered around the x-axis, then the stronger the correlation would be. Okay, so that's a residual plot, and identify any outliers. So we can see either by looking at the original graph, I think, or the residual point that goes with that, which, by the way, if you click on it, it will give you the residual value as the y value, the distance between the y value and the line of best fit and at that point. Okay, but the outlier itself appears to be the point 4, 3.2. So let's add that in here. So 4, 3.2 is an outlier. Okay, so then it says, let's take that point out since it's an outlier. So to do that, you need to go to your table and physically take that point out. Okay, and then if we take that point out, and then, oh, that's interesting. What's happening here? There. I take that point out. Then notice what happened to our R value. It got a whole lot stronger. Okay, so it says here, repeat the regression with the outlier removed, record the new line of best fit and the correlation coefficient, and discuss the impact this has on the reliability of the model. So, the new, move this up a little bit, the new correlation coefficient if I could type, it would help, is 0.9679, meaning the correlation is very strong now, and this model is a much better fit for the data. Okay, so by removing that outlier, then you end up with a much better model for your data. And I guess I didn't actually write down the new equation, which we were supposed to do. So the new equation, the new line of best fit, you can just write this underneath it, doesn't matter, is going to be y equals, the new m value is 0.2294448 x minus, because the new b value is negative, 0.12638. Okay, and so with the outlier removed, that's your new line of best fit. The correlation coefficient is much higher, which means that the correlation is actually quite strong, and really it was just that we had an outlier getting in the way of things there. Okay, if you have any questions about using Desmos, just shoot me an email.